10 kilogram block lies on a rough inclined plane as shown in the diagram above. A light, inelastic string is attached to the block, passes over a smooth pulley, and has another 10 kilogram weight attached. The block is on the point of slipping up the plane. Find the coefficient of friction between the block and the plane. So let's start by considering the weight here. So we know it's a 10 kilogram weight. I'm going to take G is 9.8 once again. So acting this way, we have 10G, which is 98 newtons. Acting this way, we have the tension. Since those are the only two forces acting on this object, it follows that T is equal to 98 newtons. Now let's think about the block. So 30-degree slope, here's the block. So 10G once again, because that also is a 10 kilogram block. So we've got 98 newtons going that way. We would have a normal reaction this way. The tension, which is 98 newtons, is going that way. And it's limiting friction, and therefore mu r going this way. Any movement is going to be along the slope, and so all the forces ought to be either parallel to or perpendicular to the slope. So let's resolve this 98 newtons, which will go partly that way and partly that way. So if this is 30 degrees here, this angle here would be 60 degrees because this would form a right angle down here. And then this angle here would be 30, which means that going in this direction we would have 98 cos 30, and down the slope we would have 98 sine 30. So if we consider perpendicular to the slope, we would have R is equal to 98 cos 30. Let's just call that 1 for now. And then if we look at parallel to the slope, we would have 98 going upwards, and downwards we have got 98 sine 30 plus mu r. Sine 30 is a half, so 98 sine 30 is 49. Take away 49 from each side, and we get mu r is equal to 49. So mu is equal to 49 divided by r, and then using 1, we get that mu is equal to 49 over 98 cos 30. And that we just need to calculate. So we've got 49 divided by 98 times cos 30. And that is 0.577. Correct to 3 decimal places.